Hello everyone, this is the team from NDTCTC. In this video, we are going to discuss about DAC curve. DAC curve means distance amplitude correction curve. So by this video, I am going to discuss about how to draw a DAC curve, what do you mean by DAC curve, and what is the use of DAC curve. So moving on to the topic. DAC curve. DAC curve means distance amplitude correction curve. So by the name you can get a small idea about what's happening with the thing. So if you observe the name, it is distance amplitude correction curve. So it means that it is a curve which is drawn by considering the distance and amplitude of the sound, by considering the distance traveled by the sound and by considering the amplitude of the sound reflected sound, amplitude of the reflected sound. And if you draw a curve, then it is called as a distance amplitude correction curve. So first, before discussing about the distance amplitude correction curve, so let me explain what is the basic use of the distance amplitude correction curve. So we in ultrasonic testing, we generally pass the sound into the material and we judge basing on the reflections we get from the discontinuity. So when the sound travels in the material, when the sound travels in the material, it gets reflected back, it gets reflected back when it is interacted with a discontinuity. So we know that if the discontinuity size is larger, like if the discontinuity size is high, the reflection is more. If the discontinuity size is less, the reflection is less. So if the discontinuity size is less, as the reflection is more, the amplitude shown on the CRT screen is also higher. And similarly, if the discontinuity size is less, the reflections are less, and so the amplitude shown by the discontinuity is also less. So basically, we used to consider the defect size basing on the amplitudes. So it may be correct, but it's not correct in all the cases. It's not the correct all the cases. We not only consider the amplitude to judge the discontinuity size, we have to consider distance also to judge the discontinuity size. So how, let me explain a thing. For example, I have taken a material which has a same size discontinuities but at different distances, and I pass the sound. For example, I pass the there is a material, and I pass the sound from initial point 0 to 100 mm, 0 to 100 mm, right? 0 to 100 mm. So in the passing way, first I interacted with a discontinuity. Like I passed the sound through a discontinuity whose size is 3 mm at a distance of 20 mm from the starting. So 20 mm. So that the size is 3 mm. So basing on this thing, we will get a amplitude, we will get a some x percentage of amplitude, right? We will get a some x percentage of amplitude. So now let me interact the same sound with the same size discontinuity but lying at 60 mm from the initial point. So the discontinuity size is same as the first discontinuity, but here the distance increases. Like you can consider here, the distance from here to here, it is 20 mm, but here the distance from initial to the discontinuity is 60 mm. The initial from here to center of the discontinuity, it is 60 mm. So it means that the distance increases. So we know that if the sound when the sound travels in the material, when the sound travels in the material, the sound some of the sound gets reflected due to the discontinuity, some of the sound gets scattered, and some of the sound, what finally happens is when the sound and travels through the material, some percentage of sound get attenuated, some percentage of sound get attenuated or maybe absorbed. So as the distance increases, the loss of energies is also increases. So it means that the reflections that comes from the first discontinuity is greater than the reflections that come from the second discontinuities. It means the discontinuities, like the energy reflected from this point, is less than the energy reflected from the first discontinuity. Even though the discontinuity size is smaller, the reflection percentage get varies due to the increasing the distance. So at this point, we will observe the smaller discontinuity, smaller size amplitude. Even though the size is same, due to the increasing the distances, we observe the small size amplitude than the first amplitude. Let me take one more discontinuity of the same size, but at 80 mm, but at a distance of 80 mm, at a distance of 80 mm. So the size is same, the three discontinuity size are same, but as the distance increases, the energy loss increases, and the reflections is also gets decreases, and we observe the smallest amplitude from that particular point. So here, if you observe clearly, the same size discontinuities, but with the increasing the distances, it shows different amplitude. So we should not consider only the amplitude for judging the discontinuity. So it means that we should not consider only the amplitude to judge the discontinuities. We should also consider the distance. We should also consider the distance and amplitude to judge the discontinuity. So this is what is the use of distance, what is the relation between the distance amplitude curve, like DSA curve, distance amplitude correction curve. So like in the similar manner, we draw a distance amplitude correction curve by meeting the all the three points as in this manner, so it means that if there is any discontinuity of size 20 mm, it gets the reflection of, for example, if it is 80%, consider this as a 80 percentage, and it is 40 percentage, and the third one is 20 percentage. So it means that if there is any discontinuities of 3 mm size lies at a distance of 20 mm, it gives the amplitude of 80 percentage. It gives the amplitude of 80 percentage. And if it is at 40 mm, sorry, if it is at 60 mm, it gives the amplitude of 40 percentage. So similarly, if it is in middle of the distance, like as here, if the 3 mm discontinuities lies at like for example 40 mm distance, so it gives the amplitude, like it gives the amplitude of this point up to where the curve meets, like for example it may be 60, it may be 60 percentage. So similarly, we used to judge the size of the discontinuities. So if the discontinuity size is smaller at a particular distances, for example 60, if it is at the place of 3 mm, if the discontinuity size is 5 mm, then the reflection is larger, like the reflection is more than the amplitude, than the thing what we have considered initially. Like it means at the same distance we will observe the highest echo. In case if the size of discontinuity is larger, and if the size of discontinuity is smaller, we will observe the discontinuity, like we will observe the echo amplitude less than the DSC curve. So it means that we have to consider, we have to consider the points, or we have to consider the discontinuities whose amplitudes are greater than the DSC curve, and we no need to be bothered about the discontinuities whose amplitudes are less than the DSC curve. So this is the use of the distance amplitude correction curve. So here it has given the few more things about the distance amplitude correction, right? So various standard reflectors are used in ultrasonic testing in order to achieve distance amplitude correction. So basically, to draw a distance amplitude correction curve, we need to set a artificial reflectors with a standard distances, so that we have a particular idea of what we are catching, what we are drawing, for what we are drawing. So we use different reflectors. So among the reflector, back wall reflectors, one of the back wall the general reflectors what we use is back wall reflections, grain response, side railed holes, flat bottom holes, surface notches, distance gain size. So these are the different reflectors that we use to draw a distance amplitude correction curve. So mostly we use side railed holes and flat bottom holes and surface notches. So let me explain how to draw a distance amplitude correction curve by using the side railed holes, flat bottom holes by this presentation. Okay, moving on to the next topic. DAC curve by using the flat bottom holes. So in this slide, it explains the thing how to draw a distance amplitude correction curve. Let us move into the distance amplitude correction curve. How to draw the distance amplitude correction curve by point wise. First, flat bottom holes used to draw the distance amplitude correction curve for straight beam transducers. So considering to the transducers types, we generally have the two types of transducers basing on the sound traveling in the material. If the sound travels straightly, then we consider them as a straight beam transducers. If the sound travels with some angle, then we consider those as a angle beam transducers. So basically, flat bottom holes are generally used to draw a DAC curve, are generally used to draw a DAC for straight beam transducers. For this, use distance amplitude blocks with flat bottom holes having the different material distances. Like must choose maximum material distance more than the testing range and block material same as the test piece. So to draw the distance amplitude correction curve for straight beam transducers, take the distance amplitude blocks. So take the distance amplitude blocks, and we have also discussed about the distance amplitude blocks. Distance amplitude blocks having a same size discontinuity, but of different sizes. But same size discontinuities, but the distance of the discontinuities, the meeting distance of the discontinuities varies from one block to another block. So to draw the distance amplitude correction curve by using the flat bottom holes, take the different blocks, distance amplitude blocks, where there is a flat bottom holes, who's having the flat bottom holes of different distances, flat bottom holes blocks of different distances. And while taking the distance amplitude correction, like distance amplitude blocks, you have to take up to a certain distance. You have to take the blocks of up to a certain distance that your range covers with the related block that you have chosen. So you have to take up to the range of, you have to take the block size that it covers the range what you want to, for what you want to make a distance amplitude correction curve. So you have to take the you have to take the block of size greater than the range what you want, and you have to take the material of the same. Like for example, if you want to check the steel material, then the distance amplitude blocks is also be made up of same material, steel material. So you have to take the same material, and you have to take the different distances, like different blocks of different distances up to the range that covers by the related block. Next, calibrate the equipment before drawing of DAC curve. So before drawing the DAC curve, you have to calibrate the equipment. Like you have to make the correction error, you have to make the correction error, and you have to calibrate for range calibration for probe, and you have to calibrate for sensitivity, resolution, and horizontal linearity, vertical linearity. So before performing before drawing a DAC curve, you should be clear with the calibration things. You should be clear with the calibration things, because before drawing the DAC curve, you have to be calibrate everything. You have to calibrate the equipment before drawing a DAC curve. Next, place probe on distance amplitude block having lowest material distance and establish echo from the hole. First, after calibration, and we have taken a different blocks. First thing what you have to do is take a distance amplitude block of lower distances. So we have taken a different distances, and among them take the block of the lower distances. Take the block of lower distances and place the probe on the lowest block. Place the probe on a lowest block and catch the hole. Catch the flat bottom holes by projecting the sound towards the flat bottom holes and catch the flat bottom hole. And when you place and catch the flat bottom holes, you will observe a echo on the CRT screen. And now what you have to do is try to maximize the echo. Try to maximize the echo, like it means that when you place the probe on a block of different size, like sorry, when you place a probe on a lowest distance amplitude block and catching the hole, you will observe a echo of certain size, echo of certain amplitude, like it may be 60 percentage, or it may be 80 percentage, or it may be 90 or something else. So whatever may be the percentage or whatever may be the amplitude, the first thing that you have to do is use the gain option and set the amplitude to 80 percentage of full screen height. So you can look at here, maximize the echoes and set the echo height up to the 80 percentage of full screen height by gain control, and make a first point of the DAC curve. So here to draw the DAC curve, you have to consider, or you have to take the minimum of 3 points, and you can also choose up to the 12 points. You can also use up to the 12 points to draw the DAC curve, but to draw a DAC curve, you should take minimum of 3 points. So among that first point, I have taken a first point by placing the probe on a lowest distance, like lowest distance, and catching the hole and making the echoes height to 80% is a full screen height, and making it as a first point. And here the gain what we have set for first point is considered as a pre-level sensitivity, so this gain is considered as a pre-level sensitivity. So it means that, see, you should remember a point while drawing a DAC curve, that is, you should not touch gain option after catching the first point. So you have to catch the first point at 80 percentage. So for that you can use the gain control. And you can adjust the percentage of, like amplitude percentage to 80 percentage. So after catching the first point, you should not touch the gain option for while you are catching the second and third points. So this gain is considered as a pre-level sensitivity. Next, this procedure should be repeated on a consequent another blocks without changing gain control, and make second, third, fourth, etc. points of DAC and join all the points. So here we have got a first point by using by we have got a first point of 80 percentage by using the gain option. And now place the probe on a different size, different distance blocks, and different distance blocks, like for example like different blocks, and catch the second hole on a certain X block, and third hole on the another block whose size is greater than the second one, and the fourth hole whose size is greater than the third one, like increasing the distances, and you have to catch the different holes. And while you're catching the second, third, fourth, you should not use the gain option. You should not touch the gain option. You should not change the gain option. Like it means you should not raise and decrease the gain option, right? So you should remember this point. You should not touch after drawing after catching the first point. So yeah, like now after caught, like when you caught the second, third, fourth, the automatically the equipment, the UT the CRT screen or the UT flaw detector equipment automatically draws the curve by joining the peaks of the all the amplitudes, and making a curve which considered as a distance amplitude correction curve. So distance amplitude correction is only needed for thickness greater than 2 inches. So here we draw the distance amplitude correction curve by using the flat bottom holes. It is for normal probe. It is generally for normal probe, and it has given the thing that we should draw only distance amplitude correction curve for normal probe straight beam transducers only in case if your thickness is greater than the 2 inches. If your thickness is not greater than the 2 inches, no need to draw the distance amplitude correction curve, only to set the sensitivity, like only you set the second back wall echo to full screen height as a sensitivity reference, like you can look at here. So distance amplitude correction curve is only needed for thickness greater than 2 inches. For below 2 inch thickness objects, set second back wall echo as a 80% of full screen height as a sensitivity reference. So if your material thickness is less than 2 inches, no need to draw the distance amplitude curve. So because distance amplitude curve is serves as a sensitivity reference. So for below 2 inch, no need to draw the distance amplitude correction curve. And for a sensitivity reference, set the second back wall echo to full screen height. Set the second back wall echo to full screen height. It's enough for the material whose thickness is less than 2 inch. So this is how the distance amplitude correction curve is drawn by using the flat bottom holes, and it is generally used to draw for the flat bottom holes are generally used to draw the DAC curve for straight beam probes. Now coming to the point of angle beam probes, we generally use the side drilled holes to draw the distance amplitude correction curve. So distance amplitude correction curve by using the side drilled holes. For this thing we generally use the AS ASME reference block. We have also made a discussion about the ASME reference block. ASME reference block having a certain thickness, and it generally consists of a three holes at a different distances, different depths, and or different distances, and two notches, one on the top surface of the block and another one at the bottom surface of the block. And coming to the point of side drilled holes, this reference block generally have the three side drilled holes, one at 1/4 of the thickness, another one at half of the thickness, and the third one at 3/4 of the thickness. Third one at the 3/4 of the thickness. So these side drilled holes are generally used to draw the DAC curve by DAC curve for angle beam transducers. So okay, look into the point. Side drilled holes are used to draw a DAC for angle beam transducers. ASME reference block with side drilled holes at 1/4, 1/2, 3/4 depths from scan surface used to construct the DAC curve. So we generally use the ASME reference block where the side drilled holes, where it consists of a side drilled holes, one at 1/4 and second one at half, and the third one at 3/4 depths from the scan surfaces. First, similarly, the process is similar. The DAC catching, the holes catching process is similar for the both sided holes and the flat bottom holes. In the flat bottom holes, before drawing the before drawing a DAC curve, we calibrate the equipment. So similarly, in this also, Before drawing a DAC curve by using the side drilled holes, calibrate the equipment for DAC. So calibrate the equipment prior to the construction of DAC. Then place the probe on scan surface and establish echo from the hole at 1/4 T of depth. So first place the probe on a scan surface and first catch the first hole. The first hole means the hole whose distance is less than the remaining holes. First catch the small distance hole, and the small distance hole is 1/4. So to catch the 1/4 hole, you need to first you need to measure, or you need to calculate a values, related values like distance, amplitude, sorry, sound path value and surface distance value. So how to draw it, like how to calculate the values, we can look in the next video, like next video. Just now in this video, just observe how to draw a DAC curve. So first place the probe on a surface area, scanning area, and catch the first hole whose distance, like first hole means the low distance hole, 1/4 thickness depth, the hole of which is the hole which is lies at a depth of 1/4 thickness. So place a probe in such a manner and catch the first hole, and you will observe a indication from the first hole, and whatever may be the amplitude size, raise the amplitude to full screen height. Raise the amplitude to full screen height, 80% of the full screen height, by using the gain control, like increasing or decreasing gain control. You have to set the first point to the 80%. So which consider that as a pre-level sensitivity. So after that, after catching the first hole, you can catch the remaining holes like 1/2, 1/2 or 3/4, and you can also increase the distances and catch the different holes of 5/4, 6, sorry, 5/4, 6/4, 7/4, 9/4, as in this manner. And how to catch remaining holes other than the three holes, we can see in the next video. So in like observe right here how to draw the DAC curve. So first catching the first hole by increasing the full screen height, by setting the echo height to 80% is a full screen height. Remaining, while catching these remaining holes, you should not change the gain. And you have to catch the remaining holes, and you have to join the all the points, and so that you can get the distance amplitude correction curve. Do this procedure up to reach the range limit and join all the points. So catching the points in this manner, you have to catch up to a certain point, where your where your testing range limit covers. So do the procedure up to reach range limit and join all the points, so that we can by joining all the points, we can get a curve. We consider that as a distance amplitude correction curve. So by taking that curve as a reference point, you can, like, you have to check the materials. So basically for angle probes, there is no limitation, like there is no consideration like similar to the normal probe. So if you use the angle probe, whatever may be the thickness of the material, you have to draw the DAC curve by using the side drilled holes, right? So in the next video, we can clearly discuss about how to draw a distance amplitude correction curve by using the side drilled holes. And also in the next video, we can also discuss about how to draw the DAC curve by using the notches.